Hello everyone, in this video we will be discussing about variables and data types in C++. So we'll go over what variables are, what data types are, the different data types in C++, and we'll also take a look at them in the code editor. A variable is a name given to a memory location which can hold some data in it. So a variable name in C++ must follow some rules. The names must contain only of letters, digits, and underscores. The names must begin with a letter or an underscore. The names are case sensitive. Names cannot contain white spaces or special characters, and reserved words cannot be used as variable names. What is a data type? A data type defines the type of data a variable can store. It also tells how much space it will occupy and what all operations can be performed on that variable. In C++, data types can be categorized into three types: primitive, derived, and user-defined. Primitive data types are the data types which are by default provided by the compiler. So a few of them are integer, whose keyword is int, which usually requires 4 bytes of space, and it is used to represent integral values. Character has the keyword char. It is used to store characters. It takes up 1 byte of space. Boolean is used to store true or false values, which are logical values, and it also uses 1 byte of space. Floating point and double floating point are used to store decimal values. They have the keywords float and double respectively. And void is another data type whose keyword is void, and it is used mainly by functions that return no value. Now, what are derived data types? Derived data types are extensions of the primitive data types to achieve certain functionalities. So if you want to store homogeneous data, which is 10 integers, 20 integers, n number of integers contiguously for easier access, then we have a derived data type for that. It's called an array. Similarly, pointer is used to store the address of a memory location, and a reference or a reference variable is used as a reference to another variable. User-defined data types. We have classes, structures and unions, enums, and typedef. So structures, unions, and classes are more used for combining together heterogeneous data, and classes also allows certain operations to be performed on those values. Enums allow a variable to hold values from a given list of permitted values, and typedef allows us to rename or give give more meaningful names to given data types. So now let's take a look at all of this in the code editor. Right. So let's start with primitive data types. This is how you would define or declare a primitive data type. So it will be the keyword for the data type, the variable name, and if at all you want to assign it or initialize it with some value, you can do so as well. So in this case, I have defined a variable num, which is of type int, and it is initialized with a value 10. Here we have a character called ch of a character data type initialized with the character a. Characters, when assigning characters, you enclose the character within single quotes. Here we have a boolean value which can take the value of false or true. Float and double are used to store decimal point values, wherein double can be held to store values with more precision. Moving to derived data types, this is how you would declare and initialize an array data type of an integer array of size 10. So you have the same data type as int, so the keyword remains the same, only the way in which you declare or define the variable differs. Here we have a pointer data type. What defines or what differentiates a pointer variable from different variables is the use of the asterisk. So any variable name which is preceded by an asterisk makes it a pointer variable. And here we have a reference variable, similar to how an asterisk differentiates it from other variables. An ampersand will differentiate a normal variable and a reference variable. Let's look into more user-defined data types. So here we have a sample structure and a sample class. So to define a structure, we use a syntax, which is as follows. So we have the struct keyword, name of the structure, and then it is followed by all the variables we want to include in that structure. So in my case, I have one integer and one double, named val1 and val2. For a class, it is similar in nature, wherein we use the class keyword followed by the class name. And within the brackets, we write whatever data members which we want in that class. And also we define all the functions or the member functions which should belong to that class. Enums are declared in a similar manner, wherein we use enum, the name of the enum variable, and also the list of permitted values which an object of this variable can take place. So we have Sunday, Monday, Tuesdays, etc., all representing the days of a week. And any object of enum day type can only be assigned with values amongst this list. So for example, day D equal to Sunday. Now what we also realize is that even though we are writing it as Sunday, it actually gets assigned the value 0. So unless you specify it specifically for it to be 1 or 2 or 200, it will automatically be assigned to 0. And starting from here, they will all have values which will be in increments to the previous one. So if I have 1, Monday then becomes 2, Tuesday becomes 3, and so on. Let's try creating a structure. Let's try creating a variable of this structure. So how to create a variable of such structure? You would use the following syntax. The entire name of the structure, which is struct, demo struct, and then the variable name. But what if we have a longer structure name? Something like this. It will not be as meaningful, or rather it will be cumbersome to always have to type such a big word when trying to create a variable for that structure. So in this case, we are helped out by the typedef keyword. So what we can do is use the typedef keyword to shorten the name from struct demo struct to dstruct, or whatever you want to call it. So the syntax would be typedef, the old data type name, and the new data type name. So after I have written this, anywhere I want to write struct demo struct, I can simply write dstruct and the functionality will remain the same. So here I can just, I needn't actually do this. So I create a dstruct called s. I initialize it with the value 0 and 1. So my val1 will be getting 0 and my val2, which is the double, will be getting 1. Similarly, creating objects for a class follow a similar pattern wherein we write the class name. My class name here is demo. So if I wanted to create an object of the demo class, it will be demo d, and that is enough to create an object. If I wanted to be initialized using the constructor, I would pass in some arguments corresponding to whichever a constructor I want to call. And similar to how for structures we use typedef to rename it from struct demo struct to dstruct, we can also use the same concept for classes as well. In case we have a longer class name in which it will be difficult to always have to write that class name, we can shorten it by using the typedef keyword, where in typedef demo I'm shortening it to dem, and then I can just create an object and use all of its properties which are public. And if there are any public properties, I'll be able to use them. So these are the data types and variables in C++. Thank you.